friends, and in this video again we are going to integrate the various different forms of the expressions which can be integrated. In the previous videos we are just focusing more on the forms of the integrations which are unique in its nature, and then once you practice these kind of integrations then you will be in better conditions. So here one such form I have right now is integration of the form I is x square plus 1 over x to the power 4 plus lambda x square plus 1 dx. Now this expression you can call it as quadratic expression, and below that in the denominator you have a biquadratic expressions, or here in other terms if you want to treat these two expressions as rational expressions, then the numerator is a polynomial of degree 2 and the denominator is a polynomial expressions of degree 4. So the way of solving these kind of integration is just first you divide numerator and denominator by x square, and because of that you will get a certain form of 1 plus 1 over x square in numerator, and the denominator will become x plus minus. So when you divide the numerator and denominator by x square, the numerator will have the 1 plus, because x square will become 1 and the 1 will become 1 upon x square when it is divided by x square, and the denominator, this expression x to the power 4 plus lambda x square plus 1 will become x square. X to the power 4 divided by x square is x square, and this will become plus lambda plus 1 over x square, and this can be written as x square plus 1 upon x square plus lambda, where x square plus 1 upon x square can be written as x plus minus 1 over x whole square plus lambda, and then you have to take x plus minus 1 upon x as t, and when you differentiate it you'll get 1 minus plus 1 over x square dx equal to dt. Then after doing this, whole your expression will change into some other forms, and this will definitely fit into the one of the forms which we have discussed so far. So now I will explain the same idea with the help of a better example, because this is just a form, this is not an example. So now I will take a suitable example and then I will integrate fully to explain you how this whole thing works. So now I have integral I is x square minus 1 over x to the power 4 plus x square plus 1 dx. You can write here as 5x square also. This does not, because this is lambda x square. Now it's fine. So now what I do that, dividing numerator and the denominator by x square, then I becomes 1 minus x square divided by x square will become 1, and the 1 becomes 1 upon x square, and this expression will become x square plus 5 plus 1 upon x square dx. Now whether I need to convert this into the x plus 1 over x form or x minus 1 over x form, this one you can get just by looking at this expression, because if you have x plus 1 over x and if you differentiate it you get 1 plus, differentiation of 1 over x is 1 minus 1 over x square dx equals dt, and when you have minus here you will get plus here. So what we have 1 minus, it means our denominator should go into the form of x plus, so that is 1 minus 1 over x square upon a square plus, this you know that this is the formula which everybody might have learned in class 10. X plus 1 by x whole square is x square plus 1 by x square plus 2. This is 2ab term. Since x and 1 by x are reciprocal of one another, That's why here at the place of 2ab you are getting this 2, because product of a number and its multiplicative inverse is always 1. If you write here minus, then this plus will become minus. So here I have x square plus 1 by x square. This I can write as x plus 1 by x whole square. So x plus 1 by x whole square gives you x square plus 1 by x square plus 2, and we have plus 3. So I write this root 3 square here as it is. Now, so in this condition, now I am going to assume this x plus 1 by x as t. For that I want to clear this part of screen. So I say let x plus 1 upon x as t. Therefore 1 minus 1 upon x square dx is dt. So our expression I now becomes dt over t square plus root 3 whole square. Now this is in the form of dx over x square plus a square, and its answer. Those who know that I am writing this formula with the red color so that you can connect. Dx of integration of x square plus a square dx is 1 over a tan inverse x upon a plus c. Same way this expression will give me the value of on integration. I'll get 1 over root 3 tan inverse t over root 3 plus c. Now I have to write the value of t, which is x plus 1 by x, or you can write as x square plus 1 over x. So this can also be written as x square plus 1 over x. So this becomes 1 over root 3 tan inverse x square plus 1 over root 3x plus c. So this is the answer. Now I'll take another example to solve this particular form. So now I take one question which goes like this: is x square minus 1 over x to the power 4 plus 1. So this is looking very simple. So now what I divide both of them by x square. I'm not writing this, you can write here dividing both numerator and denominator by x square. So this becomes 1 minus 1 over x square, and this becomes x square plus 1 over x square dx. Now if you see that if we substitute x plus 1 by x as t, why x plus 1 by x again? Because on differentiation x plus 1 over x is giving you 1 minus 1 over x square dx. Suppose if you take it minus, you will get 1 plus. Since we have 1 minus, that's why we are going for this. So this form I'll better convert this as 1 minus 1 over x square upon x plus 1 by x whole square minus 2 dx. Now, so since if I, under the light of this substitution, this becomes 1 minus 1 over x square dx, and that is dt. So here I'll write this as dt over t square minus 2 can be written as t square minus 2 square, and this is going into the form of 1 over x square minus a square, and this form I'm writing here integration of 1 over x square minus a square dx gives you 1 over 2a log mod x minus a upon x plus a plus c. So we write our integral now. Here is I is, sorry, we don't need sign of integration because we have to integrate it. So it's 1 over 2a. So 1 over 2 root 2 log, this is log mod x minus a, and at the place of x we have t. So this is t minus a, that is root 2. So t minus root 2 upon t plus root 2 plus c. So this is 1 over 2 root 2 log mod x plus 1 over x minus root 2 over x plus 1 by x plus root 2 plus c. If you further simplify, it will become 1 over 2 root 2 log mod x square plus 1 minus root 2x upon x, and that x will cancel by this, and x square plus 1 plus root 2x plus c. This is the answer of this particular question. Now I take one more popular standard form, and it comes into the category of this, that is integral of under root tan x. Now let's see how. So we write I equal to integration square root of tan x dx. You can also take under root cot x, this is the same thing, or under root cot x dx. I'll solve only one. So what we do in this case, we say let tan x is t. Then you find differentiating both sides, you get sec square x dx is dt. Now we have just dx, we don't have the sec square x, and therefore the dx can be written as 1 over sec square x dt, and this sec square x is written as 1 plus tan square x dt, and 1 over tan x is t, so this is 1 over 1 plus t square dt. So we get under root. So I better say that instead of this getting the whole root free from the root, I will write here t square. Then here I'll get 2t dt. So this becomes 2t dt. So there I write again 2t. Here you write 2t dt, and then this is 2t dt. 2t upon 1 plus t square dt, and now our form becomes I is integration root t, that is under root t square into t root t upon 1 plus t square dt. Now one mistake we have done here, that if tan x is t square, so this tan square x will become t to the power 4. Now everything is fine. Down is there coming as quadratic form. So there you see you are getting 2 integral t square upon 1 plus t to the power 4 dt. So now again we are coming in the standard form, that is y quadratic expression denominator and the quadratic expression in the numerator. Now while solving, what we do, let me remove this part. So I write I equals 2 under root t square over 1 plus t to the power 4 dt. Now let me explain you again. What I assume, that I assume root x tan x as t square. So sec square x dx is 2t dt. So dx is 2t dt over sec square x, and tan square x can be written as 1 plus t square tan square. 1 plus tan square x is sec square x, and then tan x is t square, so the tan square x is 1 plus t to the power 4. This is what we have done so far. Now we have to be little manipulative here, because we need 2t square. This 2 is outside, but we can write it here. Why I am writing this? Because this is called adjustment. How? So we write here 1 minus 1 by t square plus 1 plus 1 by t square, and this 2 t square, this 2 cancel each other. We have just 2. Sorry, I think again we made a mistake. Just before going this, first we need to express this. So first we have to divide this by t square, dividing numerator and denominator by t square. Then your I will become 2 upon 1 over t square plus t square dt. Now there you saw in the previous case, we can write this as t plus 1 by t whole square plus minus something. But here in the numerator we do not have any. In the previous case, just to pay attention, that if we write here this as t plus 1 by t whole square, we need to have 1 plus 1 over t square or 1 minus 1 over t square here. because we need this term 1 plus 1 over t square or 1 minus 1 by t square, and we don't have any one of these, but we have just two. So what we do that if you add up these two form, you get 1 minus 1 by t square plus 1 plus 1 by t square upon denominator you can write as t square plus 1 by t square and dt. Now I separate because we have got the two integrals here, that is one goes like 1 minus 1 over t square upon t square plus 1 over t square dt plus integration 1 plus 1 over t square over t square plus 1 over t square dt. Now I need to break these two, so I write them as I1 minus I2. So here I write this expression as I1 minus I2. So this is I1 and this is I2. So we will solve this I1 and I2 separately, and then our answer for this will become the difference of the integral values of I1 and I2. So again I need to clear screen. So here I write I1 is 1 minus 1 over t square dt, and at the place of t square plus 1 by t square I would like to write t plus 1 by t whole square minus root 2 whole square, and at the same time here in the parallel stretch I write I2 also. So I2, on the top we have 1 plus 1 over t square, 1 plus 1 over t square, and there because when we have plus we need to make this as a function of t minus 1 by t whole square. So there I write t minus 1 by t whole square, and this will be plus root 2 square dt. Now in this case you assume t plus 1 by t as something. So t plus 1 by t as, suppose I write y, then 1 minus 1 by t square dt will become dy. So this is under root dy over y square minus root 2, and this one gives me the answer 1 over 2 root 2 log mod y minus root 2 upon y plus root 2. And here if I take t minus 1 by t as x, I am returning back to x. So I'll get 1 plus 1 over t square dt as dx. So this is dx over x square plus root 2 square, and this gives you 1 over root 2 tan inverse x upon 2, and the x can be written as t minus 1 by 2. So let me clear this part. So here I need to put the value of x here. So what is x? That is, you see this is t square minus 1. If you simplify this, you'll get t square minus 1 over t. So this becomes 1 over root 2 tan inverse t square minus 1 over this is root 2 times t plus c, and here this y is t plus 1 by t. So you can leave as it is, or you can also write t square plus 1 over t, but I would like to leave as it is. So here I get 1 over 2 root 2 log mod t plus 1 by t minus root 2 over t plus 1 by t plus root 2 plus c. So this is our I2. Now I want to clear the screen, and then my I will be I1 minus I2. So our I have taken the form of I1 minus I2, and the integral of I1 is 1 over 2 root 2 log mod. If I take the LCM, then I get t square minus root 2t plus 1 upon t will get, and that upon t and this upon t will cancel, so I am not writing this. So t square plus root 2t plus 1. Okay, and minus this part, which is 1 by root 2 tan inverse t square minus 1 upon root 2t plus c. Now you have seen that we assumed tan x as t square. So our question was integration of tan x, and we assumed tan x as t square. So wherever you have t square, I can write tan x, and wherever you have t, I will write under root tan x. So this answer will become 1 over 2 root 2 log mod tan x minus root 2, and then since this is also coming in tan, so root 2 tan x plus 1 upon tan x plus root 2 tan x plus 1 minus 1 upon root 2 tan inverse tan x minus 1 upon under root 2 tan x plus c. So this is your final answer. The same way you can find the integration of under root cot x also. So let me get rid of this part of c. You see that this is the answer of our integration under root. Our integration was I was under root tan x dx. This finally has taken the form of this, and we started with the assumption that tan x equal to t square, and this is how these kind of questions and these particular very forms can be solved. So now in the next video we'll take some more standard forms, because form just is to have the standard form, and then just looking at the form you can apply which particular formula is going to solve that form. So thank you very much, keep practicing with us, and at the same time if you have any doubt in any kind of questions, then you can write your doubts in the comment section and we'll definitely solve it for you. Thank you very much, have a very nice time.